Now we're going to go ahead and get started on our spring 2026 FRP webinar. My name is Jaden Jackson. I'm the Student Faculty Programs Coordinator at ACI. I am working with Stephanie and Danielle for this webinar. They are the heads of all of this, and I'm going to let them take it from here. Let's introduce themselves.
Yeah, that sounds good. Danielle, I'll introduce myself, and then if you want to do the same. Stephanie Walkup. I have been a member of ACI 440 since 1999, I believe. So for 25 years. And I have been involved in the competition now for about 15 years. I led the last competition in Boston in the fall. I believe it was 2022 or 3, if I can remember back then. So I am kind of leading the charge on the FRP competition, and I'm joined by Danielle Kleinhans. You want to introduce yourself?
Yeah, absolutely. Glad to have everybody here today. My name is Danielle Kleinhans. I'm Director of Engineering and Business Development for Mateen Bar Composite Reinforcements. Some of the bars that you have in your kit, no bias for sure. But I've been involved with ACI since about 2002 and brand new to the role of Vice Chair of 440G, which is the student competition committee. So happy to support Stephanie here in this webinar and in our efforts going forward. Really excited to have you all come to Chicago. That's where I live. So coming to my hometown and hosting this competition, really excited for that.
Yeah, that's great. And so I should mention I'm a faculty member at Villanova University. Villanova actually does not have a team that will compete at the competition. So I am an impartial judge, and I'm just here to support everyone in the competition. So our online registration has opened. You are welcome to go on and register if you have not. You do need to submit the advanced registration form by February 3rd at 11:59 p.m. Eastern time in order to be eligible for the competition. And that is because we do need to send out a FRP bar kit to you, and I'll show you the bars that are included in that a little later. And there are two items. It's listed as 3, but it's really 2 items that are due prior to the actual competition date. So by March 3rd at 11:59 Eastern time, you will need to complete and submit the official mix and cost form. It is an Excel document. I'll show it to you in a little bit. And in that official mix and cost form is item 2, which is a diagram with placement and dimensions of your FRP reinforcing materials and the size of the member that you are casting. You'll also submit by March 3rd a separate document, and that is a PDF of your presentation. And I'll get into the content that's required in the presentation as we move through this webinar. So again, the competition is sponsored by the American Concrete Institute, and ACI Committee 440G, which is FRP student, runs the competition along with S801. The objective of the competition is for our student teams to design, construct, and then bring with you to the competition in Rosemont, Chicago, your member to be tested. The primary goal is to achieve a low cost to load ratio, but I'll talk about some of the additional scoring that can increase your ranking points towards the end of the competition. Cost is calculated based on your batch cost of your concrete materials, the admixtures that you may use, and the FRP reinforcement. We do make adjustments for forming costs. I'll show you those later when you have more complicated geometries. And we also incorporated a new transportation cost for this competition. We do reduce the cost of your member based on some sustainability design credits, and those have not changed since past competitions. One of the other objectives is for you to develop a presentation, again in PDF format, on your specimen design and calculations. You'll include details that are provided in the official mix and cost form, and we want to know the type of failure of your member that you expect to occur. You can predict the failure load and the type of failure using ACI code 440.11-22, which is our newest building code requirements for structural concrete reinforced with glass fiber reinforced polymer bars. You'll then comply with the rules and the associated dates. Just because we've provided Chapter 22 of the sectional strength of ACI code 440.11 to you, you are permitted to use other calculation procedures or structural modeling procedures to predict failure type and load. So you are not limited to this code document, but we do provide Chapter 22, the sectional strength chapter, to you for your use. We have some learning objectives associated with the competition. One is to understand the similarities and differences between steel and glass fiber reinforced polymer reinforcing bars. So we'll start out there, and then I'll move through the other learning objectives as we go. So let's talk about FRP versus conventional steel reinforcement. Conventional steel reinforcement is susceptible to corrosion. And as a result of corrosion, which produces expansive forces, concrete can deteriorate and fall off of our concrete members. And this reduces the life cycle of our concrete members. It is not a very sustainable design when we have this corrosion occurring. And so our FRP materials are a good alternative to reduce corrosion from occurring in these members. Glass fiber reinforced polymers, as well as others, do not rust or degrade from water or chlorides or chemicals. Because they're non-corrosive, we have longer life cycle and lower life cycle costs. In addition to that, FRP bars have a high strength to weight ratio and reduced costs. They're up to 75% lighter than our traditional steel reinforcement, and they have higher tensile strength. This makes them easier to transport, handle, cut, and install, which also reduces transportation and labor costs. They are also non-conductive, they're non-magnetic as well, and GFRP, as a result, is perfect for sensitive applications like MRI rooms, utility structures, and other areas needing electromagnetic neutrality. GFRP production actually generates fewer CO2 emissions. It does use less energy, and it can enable the use of seawater, sand, supporting greener construction as well. So there are environmental advantages to the bars as well. In terms of the reinforcing bar properties, we're first going to break this down into the FRP fibers, and then also talk about the epoxy matrix, and then we'll see what happens when we put them together. If you take a look at the stress strain diagram, we can see that the fibers of the FRP bar are actually stiffer than the epoxy matrix. So when we combine the fibers with the matrix, we end up with a composite bar that has a softer or smaller modulus of elasticity than the fibers, but a higher modulus of elasticity than the epoxy matrix. When we compare the bars, and here we're showing basalt, aramid, glass bars as well, along with carbon bars, to our pre-stressing steel or mild steel, we can see that the basalt, aramid, and glass bars have a smaller modulus of elasticity, where they're not as stiff as steel bars. However, they have a higher tensile strength. Carbon matches approximately the modulus of elasticity of traditional steel bars, but has an even higher tensile strength than our basalt, aramid, and glass bars. As a result of these different material properties, we have different design provisions, and that's what prompted the development of ACI code 440.11/2022. So let's talk about some of the competition rules and provide some clarity to these. This is just a figure or a photo showing competition day from a prior event. This is the test frame that we will utilize during the competition. However, this is a competition where we were applying the load as a concentrated load at mid-span. The testing configuration for the competition changed with the last Boston competition, where we spread the load out using a spreader beam with 2 concentrated loads. And I'll show you that diagram a little later. We no longer measure displacement of the member as it's being tested, but we are only looking at the ultimate strength that the specimen achieves. So some selected rules that I've pulled out. Each school may only enter 1 team. If your school has been participating in this competition for a longer period of time, you will remember that there was a point where we allowed 2 teams to enter the competition, and we had 2 types of structures that were permitted. We now allow only 1 team to enter, and there's only 1 type of structure that's permitted. Each team must have a supervising faculty advisor, and each team must consist of at least 2 and not more than 8 students enrolled in an undergraduate program at any college or university worldwide. It is highly recommended that at least 1 team member is present during testing of the structure on competition day. We have had situations where the supervising faculty advisor was the only one present. If you're present, you will be the one that will place your member in the testing machine prior to load application. Going back to the different types of structures that were permitted previously, we had straight and prismatic or type 1 structures, and then we had straight but not prismatic or prismatic but not straight. These type 2 structures are no longer permitted in the competition. Prismatic and straight members are members that must have a constant flexural stiffness, EI, across their span. The cross-section is symmetrical and constant. We can see here that the length of the specimen must be at least 950 millimeters and must not exceed 1,000 millimeters or 1 meter. We have a center-to-center span of 900 meters, so the additional 50 millimeters allows us to have some overhang at each of the simple supports. The structure must fit into a box measuring 200 millimeters by 200 millimeters by, again, 1 meter or 1,000 millimeters long, and it must weigh between 5 kilograms and 15 kilograms. You will mark an X designating the 2 loading points that are spaced 250 millimeters apart from the mid-span. So we can see that the load is applied now through a spreader beam. The load that we will measure for the ultimate load for the member is the load P at the top. That load P is then spread to 2-point loads that are applied to your specimen. And again, those point loads are spaced 250 millimeters apart. The load is applied at each of the X locations by 50 millimeter by 50 millimeter loading plates. We ask all schools to provide an identification mark on both sides of their beams, indicating the school identification. This may be put on with permanent markers. Again, the end reactions, as well as the mid-span applied loads, are applied through the 50 millimeter by 50 millimeter flat plates. The concrete materials that are permitted are those listed in the official mix and cost worksheet. For cementitious materials, you are permitted to use a Portland cement, blended cement, slag cement, fly ash, or silica fume. Cementitious materials may not be used to coat reinforcement as a bond-enhancing agent. Aggregates must be non-metallic, and there was a question that was sent in previously to ACI regarding fibers. Fibers are not classified as aggregates, and fibers are not permitted to be used in your concrete matrix. Only chemical admixtures meeting either Aaron training, ASTM C260, or chemical admixtures meeting ASTM C494, types A, C, E, F, G, and S are permitted. The different admixtures have varying costs, and you can see those in the mix and cost worksheet. For your structure construction, curing must be at atmospheric pressure only and temperatures less than the boiling point of water. The structure may be no more than 56 days old at the time of testing, and no reinforcing supports are permitted in the 850 millimeter clear span. Reinforcing supports must be made from non-metallic materials, or they must be galvanized, zinc-coated, or coated with non-metallic materials. This has been a point of disqualification in the past. Reinforcement must be the FRP reinforcement that is provided to you by ACI in our official kits. This has also been a point of disqualification in the past when we've identified by bar sizes that are larger or of a different manufacturer than what we have provided. Student teams must complete and submit the advanced registration form again by February 3rd to receive their kits. You also must include, at a minimum, one full piece of FRP bar. That bar may be cut in any manner that you wish. No pre-stressing of any of the bars is permitted. And mechanical anchorages, if used, must be made from the provided FRP bars in the official ACI kit. The permitted FRP bars that are going to be provided to you in your kit, if you have not received it yet, include the following 6: Strongwell composite bar, MST bar, Pultral's V-Rod, SF Tech SFT bar, Gator bar, and Mateen bar, Green bar 2X. They are all identified by a colored tape that will be wrapped around the bars when you receive your kit. You can also compare the images of the bars to the bars when you pull them out of the kit in case any of the tape has been rubbed off in the process of shipping. Manufacturer data sheets may be found at the concrete link provided here, and this is also on the FRP competition website as a link, so you can open these up. When you do open up the manufacturer data sheets, you'll see something like this. Items that are included in the data sheets include the guaranteed ultimate tensile force of the bar, as well as the mean tensile modulus, and the guaranteed ultimate transverse shear. The first two are the primary materials that you're going to want to investigate and use as part of your strength calculations. So again, as I mentioned, the important properties of the bars will be provided to you in the product data sheets. It is important to note that these strengths and stiffnesses may vary by bar size. An example of that is provided here. All competition bars that are included in the kit are number 3 bars. So if you open up the manufacturer's data sheet, you are looking for the material properties associated with a number 3 or 6 millimeter bar. As I mentioned before, ACI 440 and ACI as a whole are providing Chapter 22 sectional strength of ACI code 440.11-22 to you. This may be used to calculate the flexural strength and shear strength of your member. You can also look at bearing strength and other strengths associated with this chapter. For the presentation, you can include calculated as well as predicted ultimate loads. You'll submit the presentation on the specimen design, again, as I mentioned, in PDF format. You must include your school name and your logo, which is optional, your structure identification mark, the student team member names, and your faculty advisor. You'll then move into your design procedure. In order to present a design procedure, you'll need to share with us the geometry of your cross-section, the length of your member, and predicted material strengths based on your concrete mix design. The calculated ultimate load should also be included, including the theoretical type of failure. Again, you may use ACI for 40.11-22, Chapter 22, or you may calculate the ultimate load using other techniques. You'll also provide a predicted ultimate load, and this can vary from that you calculate. Maybe you are predicting a certain concrete strength and you think you didn't achieve that, and you want to predict a load that is a little less than what you've calculated. Maybe you anticipate your strengths being higher and your bar being slightly stiffer than what the manufacturer reports. Maybe you want to increase the ultimate load that you intend to achieve. Again, this is up to the team individually, and we're looking to see both the calculated load and the predicted ultimate load. They may be the same, but they may also vary. If they vary, we do ask that you provide an explanation of the difference. I've mentioned this a few times previously, so I won't spend any more time here, but this is just the code document that will be provided to you. Next, let's move into the official mix and cost forms. Some modifications have been made to this form since the previous competition. We have included a tab 5 this time. So when you open the official mix and cost form, there are 5 tabs at the bottom of the form now instead of 4. Actually, 1, 2, 3, 4, 5, 6 tabs. Sorry, 6 tabs. So the instructions are included in tab 1. Then you will utilize either tab 2A or 2B to do your actual mix and cost work. Tab 3 is where you will develop and place your FRP reinforcing diagram. We want to see the cross-section of your member, the length of the member, as well as where you're placing reinforcement and the lengths of the reinforcement. You should identify the manufacturer of that bar that you have selected as well. Tab 4 is unit conversions that are embedded in the spreadsheet, and there is no work for you to do on this tab. Because students have had difficulty understanding the mix and cost form in the past and have submitted mix and cost forms with errors to our committee, we have provided some checks along the way in the spreadsheet. If you have errors that occur in the spreadsheet as you move through it, those errors are explained in tab 5, Errors in Mix and Cost Forms. We thought this would be an easier approach rather than you sending the mix and cost form to us in an incorrect manner and us sending it back to you. With the official mix and cost form, the spreadsheets tabs are locked down so that you may only enter data in the light blue cells. As I mentioned, you'll either work with tab 2A or tab or sheet 2B. 2A provides US units and tab or sheet 2B uses SI units. You'll make sure to complete all cells in the mix and cost form, or that will be returned to you. If a value is 0, not applicable, or none, simply enter 0, NA, or none. This is an example of the form where you can see the general information at the top, your school, your beam mark, the faculty advisor, and all of the student names with degree and graduation dates are included at the top, as well as a cell for entering your predicted ultimate load. Please don't forget this isolated cell. We have return mix and cost forms for students who have not entered that value. As a reminder, students are to be at the undergraduate level for this competition. The concrete materials that are available to you in terms of category have been expanded because we have identified student teams using more than one lightweight material in their concrete mixtures. So in the past, it was coarse aggregate, fine aggregate, and lightweight aggregate. We have now broken that down into synthetic lightweight coarse aggregate, natural lightweight coarse aggregate, and fine lightweight aggregate. You can see those expanded right here. Synthetic lightweight aggregate is manufactured aggregate, often by heating clays and shales. These are defined primarily by expanded clay or shale. Natural lightweight aggregates, coarse aggregates, are those sourced from volcanic sources like pumice or plant-based materials. Fine aggregate, like sand, is defined as that aggregate passing a 4.75 millimeter sip, whereas coarse aggregate, like gravel or crushed stone, is that retained on the 4.75 millimeter sip. As I noted earlier, fibers are not considered to be an aggregate and are not permitted in the competition. Chemical admixtures are then provided below the concrete materials. Oh, and I should note, the date cast and the slump are also items that you will enter. The date cast must be no more than 56 days from the day of the competition. A slump test is required, and your slump is to be entered in the area right in here. Chemical admixtures are now broken up based on ASTM type, air entrainment, and then the chemical admixtures A, C, E, F, G, and S. Type A is expanded to include normal water reducing admixtures, mid-range water reducing admixture, and also high-range non-polycarboxylate admixtures. You will also indicate how many bars of FRP reinforcement you have used. These are cost out at a full bar. You may not use the cost for 1.5 bars. If you are using 1.5 bars, you are charged for 2 full bars. So the number of pieces used must be a single integer. You will then enter in whether your cross-section is rectangular. If it is not, if it is an I shape, a T shape, a bulbed I shape, that is not rectangular. It cannot be comprised of subshapes that are rectangular. The section itself must be fully rectangular. The rest of the spreadsheet calculates by itself automatically in a pre-programmed state. If you have any errors, they are most likely to occur in the total volume for the mix design. Right here, we have a mix design for 1 cubic meter. That means when you total up your volumes, you should total up to 1.00 cubic meters. If you were working in the US units, your mix design should total up to 27.0 cubic feet, which is the equivalency of 1 cubic yard. Densities also have ranges that are permitted. So here is an example of the volume totaling up for the mix design for 1 cubic yard. We can see that the volume totals to 27.00 cubic feet. That is equivalent to 1 cubic yard. We also see that the volume and the saturated surface dry weights are used to calculate density in your spreadsheet. The spreadsheet, again, is set up with pre-programmed cells to calculate density based on the saturated surface dry weights and volume that you enter. If this density is not between 75 to 155 pounds per cubic foot, you will receive an error in your spreadsheet, and that's explained in tab 5. The water to cementitious ratio is also calculated for you by the spreadsheet. It is equivalent to the weight of water divided by the weight of all of the cementitious materials, including the blended cements, Portland cement, fly ash, slag, and silica fume. Batch size is calculated automatically and is equal to the batch weight divided by the density. So all costs and sustainability credits are calculated in the pre-programmed spreadsheet. A formwork multiplier of 1.15 is used multiplied by the concrete material costs when you do not have a fully rectangular cross-section. This is explained further in section 4.3 of our official rules. Transportation cost is new, and it is related to the concrete materials and reinforcement. It is a factor of 1.10 times these materials and is explained in more detail in section 4.5. The formwork multiplier and transportation costs increase the cost of your specimen, whereas sustainability credits reduce the cost of your specimen. They are explained further in section 4.4, and they have not been changed since our previous competition. For cement values less than 15%, you will receive a credit for your cost. For fly ash greater than 20%, you will receive a credit. So you can see here that while there is 25% cement content, we don't meet the 15% requirement for credit, and you'll receive 0% for your sustainability. Again, because the fly ash was used but not used in significant quantity, there is no credit applied for sustainability credit. If these values were less than 15% or greater than 20%, you would see the cost credit calculating in the spreadsheet. The cost for reinforcement, as I mentioned, is per bar. So using 1.5 bars will require you to input 2 bars into the spreadsheet. It is the number of pieces used as a whole number. A minimum of 1 full length of bar must be used. Any of the bars can be cut and the bars can be mixed. You may choose 1 Mateen bar and say 1 Gator bar and incorporate both in your design. Dimension cross-sections of members as well as the overall length of the member and reinforcement are required in the diagram tab, which is sheet 3. We are looking to calculate volume of your specimen. So we want the cross-section to be fully dimensioned as well as the length of the specimen. We also would like you to identify the FRP bars that you've used by manufacturer. That is not detailed on this slide. We'll now step through the evaluation process. You have 2 ratios that we will calculate to use for your ranking points. The cost to load ratio is R1, and it is calculated as the cost coming out of the mix and cost form divided by the ultimate load that we measure on testing day. The maximum load prediction ratio is variable R2. We calculate that as the ultimate load subtracted, or the ultimate load minus the measured load divided by the measured load, and then multiplying that by 100%. We're also incorporating presentation scoring this year. The presentations were required for the Boston competition, but a presentation factor score was not included in the scoring process. This year, if the presentation is a very well put together presentation as evaluated by the categories shown in the left column, then the student team will receive a check plus, and a presentation factor of 0.9 will be applied to the final ranking. If the students have done sufficient on the presentation, but have not really exceeded our expectations, they will receive a presentation factors of 1.0, And if the presentation is limited, difficult to follow, not clearly identified, and has inconsistencies, then a check minus will be provided with a presentation factor of 1.1. For the evaluation process, teams will be ranked in ascending order 1 through 40, we're allowing 40 teams this year, in each of the 2 categories. The final ranking points will be calculated as 0.5 times the presentation factor times the ranking for R1 plus 0.5 times the ranking for R2. For example, a team that takes 3rd place in the cost load ratio, R1, and 6th place in the maximum load prediction ratio, and receives presentation factor with a very well put together presentation of 0.9, their ranking points will be calculated as 0.5 times the presentation factor of 0.9, the ranking of 3rd place, plus 0.5 times the ranking of 6th place. And that will give them a score of ranking points 4.35. Ties, if they occur after the final ranking points are calculated, will be broken by the ranking in the cost load ratio category R1. Past disqualifications, as I've mentioned throughout the presentation, have occurred for FRP bar size and type used beyond those provided by ACI, specimens that don't meet the size requirements or fit within our 200 millimeter by 200 millimeter by 1000 millimeter box, reinforcement protruding from the end of the specimen that does not fit the length requirement, bars coated beyond any coating provided by the manufacturer, the specimen being too light or mostly too heavy, and multiple members being brought by the teams. We've also had disqualifications for the official mix and cost form not being completed sufficiently. While we have sent these back to teams in the past to allow them corrections, some teams ultimately still were not completing the form sufficiently. We have taken some steps that we hope will improve this moving forward. I've highlighted the competition schedule several times, so I'll just put it back up on the screen for you for one moment here. At this point, I'd like to open up the webinar to any questions, and I do encourage teams to access the frequently asked questions that Jaden so helpfully continues to update on our ACI FRP Composites competition webpage.
We do have a few questions. Good afternoon. For any of those who have emailed me for letters and invitation letters, if you have not received a response to yours, leave for the team. Gustavo, I'm going to reach out to your team right now. Can I apply later and send the names of my team members later? That was the one question we have.
We have had teams who have submitted, say, they need 2 students, Jaden, as a minimum. So it needs to be a minimum of 2 students and 1 faculty advisor. We have had teams who have added on students later on. I would defer to you as to whether we want to continue to allow that or not. They have to have a minimum of 2 and a maximum of 8.
Typically speaking, if your team does fill out the registration round, we do let you fill out the team members later as part of the submission round, but your completion of the registration round is a priority in finishing, in being a part of the competition and being officially applied for the competition. Wait, I see my screen, but I don't think you can see me. So if you are looking to be if you are like unsure of who is going to be on your team now or later, it is best to just apply now, submit your registration round now, and then fill out the remaining team members. And maybe you had an advisor switch. We had some teams who have their advisor switch early in the year for their student competition team, amongst other things. If you are one of those teams or one of those people, just be sure to have your advisor fill out the information for who it is they know will be participating if you don't know entirely as the team captain, if you're an advisor in here, for instance. Um, and if you are a student team captain, yes, then at this moment in time, put your information into your team's information so that you guys can receive your kit. Of course, with the intention in participating in competition, but it is okay to fill out the remaining team member section post.
If I could just add one item to that, we do
Mhm.
have a limit on the number of teams who can participate just due to a scheduling at the ACI convention. So I also encourage teams that if you have submitted the form and received your ACI materials, and something happens that you can no longer participate, it's really important that you share that with ACI so that we can allow teams who might be on a wait list to participate. And we wish that we could open this up to more teams, but we are limited in terms of the competition day of just moving through the specimen testing. There's also a question about where will the beam model be built? I want to reinforce that the members, the specimens, will be built by you prior to coming to the Rosemont Chicago convention. You will build these at your own college or university, in your own lab, outside, wherever you can build these, but you bring them with you to the competition. In the past, teams have usually tried to use them as a carry-on on the plane if they are flying. But this is something that you'll want to check in with the airlines, let them know what you need to bring with you. It either needs to be packed very well to prevent breaking if you are checking that luggage. We have had teams come to the competition and their specimen ended up breaking during the flight in checked luggage. We have had teams that have carried the specimen onto the plane as their carry-on, but I do highly encourage you to check with the airline. Who will bear the travel costs? Travel costs are handled by the students, their faculty, their colleges and universities. ACI provides the FRP kits and does pay for shipment of the FRP kits. But any travel and any shipping, any travel for students, advisors, and any shipping or carry-on of the specimens is up to the student teams to fund.
Yeah, I would just chime in, registration for the ACI convention itself for students is, maybe you can confirm, Jaden, is it free or quite nominal? It's quite low. Maybe I can pull that up really quick here.
Mm-hmm. Yeah, that's probably the least cost, right, to the students incoming.
Absolutely.
And again,
And then I know we do provide lunch to the students on Sunday during that day as well, just as a means of having them not need to go off site and purchase lunch and come back and potentially, have some issues with the schedule. But lunch will be provided on Sunday to student teams as well.
we build an extra beam and test in our lab prior to the competition. This is a good question. So the question that's in the question and answer is, can we build an extra beam and test it in our lab prior to the competition? All of the materials that you mix for your final batch, okay, must be included in the mix and cost form. So if you are casting 2 specimens from that batch, then your batch volumes need to account for both specimens. So this is not prohibited per the rules, but you would need to put those batch materials in. If you are doing, say, trial specimens, and you're batching, you're testing, you're batching, you're testing, you're batching, you're testing, again, whatever specimen that you bring to the competition, we need to know the entire batch materials that you used. That includes, and I should have mentioned this, you need to bring cylinders. Let me actually pull it up and share that screen, Jaden, because this is another point here. You need to bring a cylinder to the competition with your materials as well. So when you batch materials, you will batch the volume needed for your specimen, or two if you're going to cast two, the volume needed for the cylinders. We need, let's see, hold on. I got to find the section here. Sometimes finding this is more difficult. And you also need to do a slump test. So let me just.
If you hit Control F, you can type in what you're looking for too.
Yeah.
That's what I always do.
I know I have it up here too. Sometimes I think I can find it better, but maybe I can't.
I
Here
get
it
what
is.
you mean.
Yeah, here it is. I did find it, Jaden. I did. Okay, material costs are calculated as the sum of the costs for the materials used. This is in the batch, times the sustainability credits in terms of section 4.4 and the cost with the material cost multiplier and additional complex formwork cost adjustment and transportation cost multipliers. At a minimum, the team must cast material sufficient for one slump cone, 4x8 cylinders. You need 3 cylinders that you test at 7-day strength, and you will report that strength in the official mix and cost form. You also must bring with you to the competition with your specimen 1 4x8 cylinder. Okay. We weigh that cylinder at the competition, and we weigh your specimen at the competition. We use these for density calculation and to verify materials are as you entered into the spreadsheet. So I think that answers that question.
Do we have any more questions before we get ready to wrap up? We're going to wrap up our questions in about 2 minutes.
And I should say, just because you don't have a question now during the webinar, you are welcome to send those in to our email, and Jaden will forward those on to Danielle and me if he needs any clarification from the ACI 440 committee members.
And I did see a question asking if the webinar would be posted. It will be posted on the competition website right after the webinar is over. Give it a day or so at the most, but it'll be posted to the competition site. And you can watch it from there. It'll also be on the ACI YouTube page for those who are following that.
I'm really excited to see 56 of you joining us in the webinar. I hope this was informative, and I really look forward to seeing as many of you at the competition in Rosemont, Chicago as we can.
Absolutely. Do we have any more questions for the FRP kit? Can the student body order it? Or does it have to be it can be whoever the team captain is, whoever is filling out your competition portal is technically the person who's ordering it, because you guys are going to fill out that form that says where we are shipping it to you. And every week those kits go out, usually on Thursdays or so. Towards the end of the week, those kits go out all in one group, all the kits. So if you ordered your kit Monday or Tuesday, for instance, of this week or today, Monday, Tuesday, Wednesday of the week, and you haven't had it received yet, it is more than likely to be going out towards the end of every week if you're looking at the timeline for when you'll get it. As far as who can apply for it, whoever your team captain is, who's handling submitting your information on your competition portal is the person who's technically ordering it. And the form you guys fill out will also, so I've had to go in on the ACI side of things. We have been receiving students' teams who are submitting to receive more than one kit. Each team is only receiving one kit. So for those who, I know nobody asked this question, but for those who are wondering if they can apply for more than one kit, every team is only receiving the one kit. So I know that some people are changing it to say, hey, can we get 2 or 3? Everyone's only getting one kit. So. Yeah.
And then Jaden, if I can just answer the last two quickly here. Saeed, you asked if we have 2 trial specimens and 1 for the competition, then the cost should be calculated for all 3 beams and all the cylinders. Here's what I would say. If you're doing some trials to see what design you want and they're batched separately, there's no reason to include that batch material in there. It is the final batch that you need to account for. Okay, so if you're doing trials along the way, and I encourage teams to do that, the trials don't count. It's the final batch that you batch out. And then the anonymous attendee, I would highly recommend not moving to an exact length of 950 millimeters, because the chance of that judge measuring it with the tape measures that we have that day, and our tape measures are what we use, you can't bring your own, at 949.5 that's not going to serve you well. So aiming for 955, right, I think would be maybe my suggestion. But we have had teams disqualified because they're pushing the limits like this. And I know you're trying to get your volumes down because then your cost is lower, but I would encourage you to not push the mark that far. The same thing with the bars. Sometimes the manufacturers cut the bars like right at 1,000 millimeters. Just make sure they're not 1,001. You don't want to be, right, disqualified for something like that. Just check all the measurements before you come. Check the weights before you come.
I have another common question here from Jose that happens to some of us. I'm registering, but it doesn't let me finish because my faculty advisor hasn't sent the verification letter. What do I do? If you are waiting on your faculty advisor to send a letter, and we do need that letter because that letter does say that, hey, this team verified by a faculty advisor is going to be participating. And so if you have the letter and you are having trouble submitting, you can send that directly to me and I can submit it for you. But if you don't have the letter, that's not too much of a step we can get around. You don't need a letter from directly your advisor. In that case, I would look at maybe another faculty advisor or somebody who can speak on behalf of your team for the school. But via the fact that it is a official letter from someone on behalf of your school, that is a letter that we do need to verify your participation as a team in the competition. If that makes sense. So if you are just having troubles with your submission, though, and you do have your letter in already, you can just send it to me and I can get it into your team's competition portal. Good question. And so I know that some of our professors who run our competitions, like Stephanie, have other things and meetings that we have to do today. So if you guys do have any other questions, feel free to email me at students@concrete.org. And I will answer all your questions that I can and get the rest to Stephanie and Danielle. Any closing remarks, anyone else? Stephanie?
I don't think so. I think it's going to be a great competition, and I just look forward to streamlining this a little more with the students with the mix and cost forms. And don't hesitate to send in questions. It's easier for us to answer the questions ahead of time than for you to have errors in something when you come to the competition. Our goal is to not have teams disqualified. We'd rather answer those questions ahead of time. So I thank you all for participating in the webinar and attending today, and I look forward to seeing all of you.
Yeah,
Yes,
good luck
thank
to
you
all
so much.
teams and see you all soon.